Okay, we have liftoff. Thanks very much, everyone, for joining us today for the latest Working in Sustainable Tech meetup. Very nice to see you all. We've got an exciting couple of speakers today talking about the issue of plastic waste, which is becoming ever more pressing on the environment. Most plastic ultimately ends up in the environment. Most of it, in fact, ultimately ends up in the oceans. And there's evidence that it's lasts there for many years and comes back and bites us in various ways. There's almost nowhere on the planet, including our own bloodstreams, that hasn't got microplastics wandering around in it. So anything we can do to prevent that is obviously very welcome. Quick word about the Working in Sustainable Tech meetup. We aim to showcase not just the technologies that people are working on that are in line with the UN Sustainable Development Goals, but also the skills and the techniques and the work that people are doing within those companies to achieve that. Our hope is to inspire people to take career paths that are sort of green jobs, as we often hear them termed, and that we are able to build the technical skills for sort of meeting the challenges that both climate and environmental factors are setting us. So with us today, we have two fantastic speakers. First up will be Paul, who is the head of packaging recycling design at Recoup, which is a trade body for recycling companies. And following him is Josie Holstein, who's the CTO of Everalis, and they are working on biocatalysts that will break down plastics and prevent them from going into the environment. So I think that's enough from me. Without any more ado, I think we can pass over to Paul if you're ready to give us a quick rundown of the view from the Recoup camp. Thanks very much.
Okay, we'll share. I'm trying to start the PowerPoint off. Okay, can you see that okay? Thank you for the invitation to speak today. First off, I've got quite a few slides and I think I've only got 10 minutes, so I'm going to be rushing through a few of them, but obviously any queries, any questions, let me know at the end. Chris's introduction is interesting. Plastic waste, no such thing. Plastic waste, we tend to think of it as that sort of decries what it is. It's an opportunity. It's an opportunity to do something about it. It's an opportunity to use plastic as an in-feed for recycling as much as anything else. So as you mentioned, Recoup is a membership organisation basically looking after the whole recycling chain, plastic recycling chain in the UK and Europe. And members spread across brand owners, packaging manufacturers, packer fillers, waste management, councils, just about the entire lot. So we're quite proud of that. We think our conference, I'll mention more about that in a minute, is the one place where that entire industry comes together. So just looking at our aims and objectives, I'll talk about or try and fit in all the areas that we keep cover, or at least a bit of everything in this talk. So the four areas, policy and infrastructure, which as you can see includes on the top left-hand corner there, survey, which is household collection survey. That's where we get the figures from. So we basically call all the local authorities in the UK, all 304, I think it is of them, and ask them what they're currently recycling or what they're currently collecting for recycling, and base reports based on that. The packaging, recycling and design is my bit. That's a bit I look after. So I'll talk a little bit about how you can make packaging that you use, that you buy, that you specify, more recyclable. Sustainability and circularity and comms and engagement. Basically, communication is important two ways, as communication to the public and communication to industry. Communication with industry includes the bit that I do and a fair with a few bits and pieces as well. Communication to the public, frankly, is far more difficult because you're not sure who you're talking to at any one point in time. So there are various different ways of doing that. We have a company set up called Pledge to Recycle Plastics, which we'll talk a little bit more in a minute. So that's some notes from, I mentioned the policy and infrastructure team include the plastic collection survey. That's the latest figures. Say latest, it says 2019 on the left, I think that's a year out. But basically, we as I mentioned before, we phone up the local authorities and get information from them as to what we can, what they're currently recycling, and obviously report to industry what's changed from the year before. Pledge to Recycle Plastics. As I mentioned, it's a way of communicating to the public. We do that by standing outside, for example, Marks and Spencer's in the middle of Queensgate and collaring people and asking them questions on surveys and asking them questions about what they do with their packaging, what they think about it, what they want to be done, just about anything like that. Basically, M&S pay us to do that, so that's what we do. Another example, one of our members, Danone, run a football competition for kids, Danone Nations Cup. So we basically turn up at some of the events with a stand and talk to kids and parents about how packaging recycling works and what they can do to improve things. So I mentioned that my part of this mainly is all about packaging design. So talk a little bit about that. Basically, one of the fundamental facts about packaging design is trying to understand everything it has to get through to be recycled. So these are the 5 stages of recycling. And the important thing to remember is for your pack to be recycled properly, it has to go through all of these stages. If it fails at any one of these stages, then it's not recyclable or not classed as recyclable. For example, the consumer, normally it's curbside collection, as per the second picture there. Anything that's not collected curbside at the minute is not classed as recyclable, to give you an idea. There are lots of little activities going on to change that. The biggest emphasis at the minute is on what we call flexible packaging or film, which we've got some front of store collections now which collect film, and we're basically trying to rush through, I think is a way to phrase it, work on converting that to proper recycled material, and then the aim is to have film collected curbside within a couple of years. Design makes a difference. We could offer as a service to our members to trial packaging to see how it will go through the sorting system. This is a couple of examples where changes have been made. So on the left there, you've got a bottle with a sleeve on it. The sorting system uses an infrared light, shines it on the plastic and works out what the polymer is by the reflection it gives back, which is fine because it works great, apart from if you do something silly like cover it with a plastic sleeve of a different polymer. So that's where we're trying to convince people like Lucozade, and to be fair, they're listening, which is why I picked these 2 out. So basically they reduce the size of the sleeve or the label so that it can be picked up by sorting equipment in both of these 2 products. There are other things that can upset the system in terms of recyclability. Material types I mentioned, colours, some colours are not detectable. Black is the main, carbon black is not detectable. It absorbs the light instead of reflecting it, so it makes things difficult to sort out. Additives, some additives don't behave very well in the recycling system. Size is important. If you've got something that's less than 40 mil, the chances are it will go through with the broken glass in the system instead of going through the plastic where it's supposed to go. We could do guidelines for recyclability. The middle one is the technical one, 70 odd pages, which has a good reputation, but one or two people said it's a bit too long, and a few others said it's a bit too complicated. So the one on the left is a summary version we did with the BPF, 20 pages, and the one on the right is one we did with the packed and wrap, and that's similar thing but in more straightforward language. So we realised that not every company has got a packaging technologist. So that's putting everything in language that somebody who like working for an NPD department or something could access. That's just an idea of how it works. Basically, you've got tables for different polymers, and they're saying on the tables, basically telling you what's good and what's bad and what's recyclable and what's not. And lastly, on the recyclability bit, we do certification. So Recyclas is a European group, and we keep the accredited certification auditors for the UK for Recyclas. So basically, we'll put packaging through the system, work out whether it's recyclable or not, or how recyclable it is, give it a grade, and yeah, and we'll pass that on to our customer. I mentioned I'm going to go back a stage or two now to the policy and infrastructure, because what I was asked to cover as part of this was some of the stuff that's going on now and in the future and what it all means. The emphasis in the last year and a half or so has been away from some of the more, so to say, obvious questions about what's recyclable and what's not. And there's a definite shift towards looking at laws that are coming in and various other bits and pieces. This is an attempt at summarising on one slide, which is not easy. Extended producer responsibility is a law that's coming on. Plastic packaging tax is a law that has just started. April the 1st that came in. DRS is deposit return schemes is something which may or may not take off. Lots of people in the industry have different opinions about that. Consistency just means, why is it all the local authorities in the UK have different ideas about what could be collected and what shouldn't? Why not change it and make it all do the same thing? Single-use plastics is basically summing everything up and trying to work out what we should be banning, if anything. And the bottom one, environmental claims, that's an interesting one. People are putting this is recyclable on a product that isn't recyclable. It's something we need to stop. So just a quick review on those. Extended producer responsibility means, unlike now, producers will pay the full net cost recovery of the packaging put on the market. To put that into context, the amount that one company, so picking on somebody the size of Tesco, would pay under this new system is about the same as the entire industry pays at the minute. That's what we're increasing. That's the sort of increase that we're talking about. It's a huge increase in cost. So yeah, 2.7 billion in extra cost. DRS, as I mentioned, deposit return schemes, is something which is due to happen in Scotland in August 2023. The rest of the UK can't really make their mind up yet. I think most of that is down to cost, because someone somewhere has got to pay for this system, and at the minute nobody's put a hand up and said, yeah, we'll do that. So that's part of the issue regarding that. Sorry, I missed the bit on the left, consistency. I mentioned that before. That's basically looking at the 314 local authorities in the UK and trying to get them to do something in a similar way or the same way if possible. And I mentioned the plastic tax, 1st of April, that came into effect. We're still getting questions and queries about what that refers to. The tax applies from the last substantial modification. So, okay, fine. So who makes that modification and who is paying the tax? If you've got packaging that's produced by 2 or 3 different suppliers to lead up to the product that you actually get into the site, into your site, then it's difficult, it's probably the right word, to ascertain who should be actually paying the tax at the present. So last slide really is just a reminder, mention of the conference this year. Anybody interested in that, please let me know. It's free for Recoup members, but we do have the ability to give 1 or 2 free passes away if it's something that you're interested in, and something that you would look to be members in the future, possibly. That's me. Basically, one last thing I need to mention, because when Chris was asking me to come on here, the question was around what's happening in the future and in terms of recruitment in particular. A comment I would make on that, I used to be a packaging technologist, who was one of them in every one of the big companies around, tooting along, doing things like testing materials. Because of all this new legislation that's going on at the minute, what we're finding is that packaging technologists are in demand. There's not enough of them to satisfy the ask. So every company, I think, in the UK basically is going to find themselves dealing more with packaging. They have to, because of all the laws and regulations that have come out. So how do you deal with that? I mean, yes, you can, as I say, join Linkit, that helps, but I think, as I said, there is, or I have seen an increase in the amount of packaging jobs going around at the minute. So that's sort of answered the question. Okay, that's me.
Thanks very much, Paul. That was a lot to pack in a very dense 10 minutes there. I appreciate your thoughts and the call out to the world for more packaging technologists. I guess actually is a somewhat rubbish segue into the next speaker. I think there's also obviously going to be people needing to be working on the processing side of this. If we get more and more materials coming back into the stream, there's a lot of different techniques coming along, and I think hopefully we will learn a little bit about very different level of focus to the sort of macro level of government departments and packaging companies. So I'm going to hand over to Josie to pick up the story from the micro end of the scale. Over to you.
Yes, thank you very much, Chris, for the introduction, also the opportunity to speak here today. So yeah, my name is Josephine Hostin. I'm a founder of Everalis, and we develop enzymes for a circular plastic economy. I have a more general introduction, but I will go really quickly through that. So the global plastic production reached 360 million tons in 2018 and is expected to double over the next 20 years. And still, like, more than 90% of the plastics produced is derived from virgin fossil feedstocks and not from recycled materials. The main sectors for plastic waste generation are packaging and textiles, and in general, around 20% of the plastic waste is collected for recycling, but the other 80% end up either in landfill or they are incinerated for energy recovery. There are many different types of plastics, but there are 7 main classifications, and there you can find them here on this slide. They have these symbols with these numbers, and then you can find them also on the corresponding products. Mainly or commonly recycled are polyethylene terephthalate, high density polyethylene and polypropylene, but not yet widely recycled are polyvinyl chloride, low density polyethylene, polystyrene or polyamide, for example. And then some of these plastics are also quite toxic, like polyvinyl chloride, polyurethane or polystyrene, because of additives or plasticizers. The recycling approaches are divided into mechanical and chemical recycling, but mechanical recycling is predominantly used. So around 98% of the plastic waste is recycled. So the recycled plastic waste is recycled mechanically. So then this means that the waste is washed, ground, melted and reformed, but the chemical structure of the polymers is untouched. So the results are pellets or granulates with usually lower quality compared to the original materials. So the chemical recycling approaches, they actually tackle the chemical structure and alter it. So for example, you can perform pyrolysis or gasification, and the products that you can get out of these are naphtha, crude oil, or fuels. Then you can also chemically depolymerize the plastics using hydrolysis, methanolysis, or glycolysis. And then the product will be monomers that you can purify and use to repolymerize them, and you will generate virgin grade materials. But chemical approaches often use harsh chemicals or high temperatures. So a more green approach is to use biocatalysts or enzymes, and these can also degrade synthetic polymers and lead to the monomers. So for example, if you have PET, polyamide, or polyurethane samples like PET bottles or like textiles, you can enzymatically and selectively depolymerize those materials to generate pure monomers. Then you can purify those monomers, repolymerize them, and you can get virgin grade materials. So we believe that enzymes can selectively and truly recycle plastics into virgin grade monomers in an environmental friendly and cost effective manner. And our mission is to develop efficient enzymes for key plastics, for example, in textiles, and build the processes to make these plastics truly circular. For this, to find enzymes, so today there exist only few enzymes that have been published in the literature that can actually degrade plastics efficiently, but so far only one enzyme is industrially used to recycle plastics. So we developed an ultra throughput screening technology to find those enzymes and make them highly efficient. So you can find new enzymes in nature. You can, for example, collect soil or water samples from different environments and extract the DNA and make huge enzyme libraries from this. Also, you can search in public databases for enzymes as well. So if you generated your library, we generate these water and oil picoliter droplets using microfluidic devices. So each droplet represents a reaction chamber, and they are in the picoliter range. They are highly monodispersed, and we can generate 1,000 droplets per second. And in total, we can screen enzyme libraries of 10 million enzymes per day. So in a second device, we can sort, in a second microfluidic device, we can sort those reactions. And if we have a positive outcome, we can find optimal enzymes. And we are sorting at 1 kilohertz. And to find those enzymes, we are 1,000 times faster than current state of the art. In addition, if we have found an enzyme that can degrade plastics, we can also improve them using our technology. And we do that by using directed evolution. And this technique has been awarded in 2018 with the Nobel Prize. So we can, for example, take an enzyme, we can diversify it to generate a library of different variants of this enzyme. Then we can screen these libraries using our technology, and we can find improved variants. You expect in one round to get an improvement of 5 to 100 times. So we using our technology, we found so far a PET degrading enzyme and improved it 500% in one round of directed evolution. So the advantages to use enzymes are summarized in this slide. So enzymes, they are highly selective for their target plastic, and they can also deal with more difficult conditions like, for example, mixed plastics, colored or contaminated plastics. These enzymes are tailored to work under specific conditions. For example, you can use them at different pHs, crystallinities of the material, temperatures, and also salinities. So the enzymatic production of monomers does not require harsh chemicals or temperatures, and in general it uses 70 to 83% less energy for this. So this is predicted, and also the environmental impact should be reduced by 95%. So the production of plastics from enzymatically recycled monomers saves resources as well. You basically eliminate the use of crude oil, and also it uses around 35 to 42% less energy in the supply chain and produces 8 to 21% less greenhouse gases. And like I said before, you can generate virgin grade materials afterwards. This is the team of Everales. So we have also 2 other members in the audience today, which is Lisa and Daniel. And 3 other members, they couldn't participate today, but Tomek and Mariana, we developed the technology in the lab of Professor Florian Holford at the University of Cambridge. Like we said at the beginning, we are early stage spin out from the University of Cambridge. We developed the technology here and found this PET degrading enzyme and improved it. And to generate a business out of this, the idea came in 2020 when we participated at the postdoc business plan competition organized by Cambridge Enterprise. And we finally founded the company last year. We are filing our patent right now, and we are applying for grants and searching for investors. With this, I would like to thank you for your attention, and I'm looking forward to the discussion. Thank you very much.
Thank you very much, Lucian. There's a lot to take in there. It's very innovative processes going on there. Learned a lot on the way through that, many things I've never heard of, so got plenty of questions.